Hello, I'm Pat Lee, Senior Director in the Cloud Apps and Desktops group here at VMware.
And I'm Luke Wignall, Manager of the Grid Performance and Engineering team at NVIDIA.
And we're here today to talk about how you deliver high-performance 3D desktops with VMware Horizon and NVIDIA Grid vGPU. Some of the things that we're going to cover today, we're going to first understand why we're actually looking at graphics and what's important to use from a user perspective, how you can use Horizon and Grid together to deliver great graphics experience, talk about NVIDIA Grid 2.0 in detail so you understand what's available and how it's important to you. And then we want to talk about how do you actually deliver and get that experience and performance you need to be successful. And then finally talk about some resources that will allow you to actually get up and running quickly. So why do we care today about 3D workstations? So today, organizations have had to choose. I can either deliver mobility to our users, or I can deliver collaboration or security or performance. But it was difficult to deliver all 3 or 4 of these solutions for our users. And the reasons why were because everything was siloed. I either had a mobility solution around laptops, or I had a collaboration solution around certain software, or security, I had to install this really obtrusive software to give a lockdown experience to my users. This made it really challenging to deliver the type of solutions that our users are demanding today.
There's also a tremendous amount of cost associated in making all of these different silos. Like trying to actually achieve every one of these, or as many of them as you could, you'd end up having to make a tremendous investment, certainly beyond just dollars, but also in people and skill sets and everything that went into the management and orchestration of trying to achieve that.
Exactly. So together, VMware and NVIDIA are now delivering graphics-accelerated digital workspaces. And this actually gets rid of the barriers and silos to deliver a single unified solution that gives you the benefits of mobility and collaboration with the security that IT requires, but the performance that the end users desire and need. And this is something that can only be done by VMware and NVIDIA working together. And that's what we're going to sort of talk more about in detail today, about the collaboration and what this brings about and what it means for us.
So let's talk a little bit about what NVIDIA Grid is really bringing to the table. What's different, what's new that NVIDIA brought into this that became part of this big collaborative effort? It's been a long-standing issue with end-user experience. Whenever you try to do anything remote, you would always run into issues with end-user experience. And if you go to any sort of long-standing struggling project, you would hear comments about poor adoption, and always the root cause of that was end-user experience. And ultimately, if you look at all devices today, everything we're surrounded by, if I had my phone here, or if I had a laptop or a PC, it didn't really matter, tablet, you name it, there are some form of graphics delivery included in every one of those devices. And so for us to expect that you would walk away from that device and sit down to your virtual desktop and not expect a graphical experience, or to accept a limited graphical experience, it was crazy. So what we've done is we've created a means of delivering graphics into the cloud so that you can consume your apps, your desktop, anywhere in the world with that great end user experience. It's important to note that I think there's this sense of, well, that's 3D graphics, it's high-end designers and engineers, but the reality is whether you're a salesperson or a office worker or a 3D engineer, all of these people and all of these roles expect to consume great graphics. They expect to have a good experience. And so any workload needs to be empowered with that sort of end-user experience.
We were having a great conversation earlier and saying that YouTube is now a business application. Think about that.
Yeah.
That means we have to deliver high-performance, high-quality video to every user if we're going to be successful today.
So I think it's important to note that there are multiple layers to the people that get benefit from this solution. Users obviously benefit. We just talked about that, right? The increased performance and the mobility, the flexibility piece, right? And that equates, you can't ignore that last point across the top about improved productivity, because productivity is something that impacts not just the dollars and cents, right? I'm more productive, so I'm more effective for my business, and my business benefits from that. But also, it's happier employees, right? I mean, they're not wasting time, they're not struggling with inefficiency. They're able to get more done and maybe condense their day into a normal work day than having to extend that because of some productivity issues elsewhere. And then, of course, IT benefits from management and flexibility, the hallmarks of virtualization, but now being able to extend things like data security around apps that would have normally been installed locally can now be centralized in the data center. The data next, we're bringing the compute, we're bringing the data, all of that's going into the data center.
Yeah.
We're unchaining the users and allowing them to roam freely. This is a powerful, flexible solution that IT can embrace as well.
And absolutely, again, it's not just about graphics users professionals. And we were talking at the GTC conference earlier this year, and we had a large financial services and media company on stage talking with us about how they're delivering 4 monitor desktops to their traders and their news reporters that has to be secure and protected because, again, the viability of the company, but they need the high performance required by a GPU to deliver that.
That was actually a really interesting case study because at that panel we had an AEC firm, right? Architectural engineering, construction. You're thinking CAD apps and all the things that go with that. And on the other side, we had manufacturing, right? Obviously, CAD/CAM and all of its horsepower. And in the middle is this financial institution that you would think would be the light user story. But as the story unfolded, it was pretty clear that their needs were extreme and that things like 4K and real high quality experience for the end user were important to that customer.
Absolutely. So now we're going to talk about NVIDIA Grid. I'm going to hand it over to Luke to talk about in detail.
So let's dig into kind of the nuts and bolts here. So what NVIDIA has done, in the past it was a simple, if you will, we think of hardware, this discrete video card, this graphics card that would be inside your physical device, and then we would have this powerful driver on top of it, which is great if you're talking about discrete physical machines. But if we want to expand that out, to put that in the data center, turn that into an enterprise solution, and begin to offer flexibility and manageability, to really embrace all the benefits of virtualization, we had to break that stack up, and we had to turn it into something that it had never been before. So first and foremost, and this is a recent development for us in terms of hardware with the M60 and M6 card, we've now moved to a full Tesla card for hardware. So I'm going to start at the bottom here. The Tesla card is designed to be run 24/7 in a data center under extreme abuse, right? The idea here is that this isn't workers showing up at 8, leaving at 5, and then the machine gets turned off. This is 24/7, around the clock, follow the sun, potentially, productivity gains. So that hardware is really critical. Now, layered on top of that is Grid software. Why is it a layer? Because we wanted to separate between hardware and software to allow us to increase our ability to be more nimble in software delivery than we'd ever been before when we were locked with a driver to hardware. So this is truly new for us. This is software on top of that hardware. And then on top of that, all of those apps that are now empowered, because it is still within that software, our driver. So all of the support, all of the certifications, all the apps that have been embracing our technology for years still just work. So you can expect to have that same experience on the stack. And then layered on top of that, maybe most importantly in some ways, we've now aggregated the most critical users doing the most critical work on the most critical apps in the data center. Right. Uptime, 5.9 support, that has become a paramount concern. And so, especially if we're talking productivity, if we've given you that productivity gain, we don't want downtime. So SUMS is something that's absolutely imperative that we layer on top of that entire solution. So now we have a full platform offer instead of simply a hardware one.
So we have enterprise hardware, enterprise software, now enterprise support to really match what enterprise customers need.
Exactly. Now, we've broken this into really 3 different products. And this is from direct interaction with our customers and hearing what they need. So starting really on the right, you've got virtual workstation. This is the traditional Quadro using designer, engineer, somebody that's doing 3D apps, you name it. And it's really the full spectrum of that workstation user. Now, that's great. That seems like a very obvious user group. But then there's also virtual PC, and that's the business PC user, and they have some form of graphics. It might be integrated, it might be a more consumer level graphics card, whatever, but they're expecting that graphical experience. And so we also have a product that delivers just enough graphics to meet the needs of those users versus the high-powered graphical needs of that workstation user. Then we have virtual applications. If you're using Horizon, RDSH, you want to deliver apps, because desktops aren't part of that equation, we can also deliver a great user experience with those apps. Now, what's really cool is we've also bundled those together so that if you have, say, virtual PC or virtual workstation, you're delivering that virtual desktop, either of them, then you want to layer on virtual apps. If you want a truly flexible hybrid model, you can do that.
That's great. It's really great, especially think about education where they need to provide a desktop to all their users, but I only want to give AutoCAD to some.
Right.
It's a great solution to be able to use virtual apps combined with virtual
Correct.
desktops in that case.
So let's actually dig into some of the apps and some of the use cases. So with Horizon apps, I mean, I have an ability on Windows platforms to deliver streamed applications. I can, as you just said, I can deliver this app or that app, and I can have great flexibility or policy-driven opportunities to deliver apps on an as-needed basis. We support a variety of solutions, but vGPU obviously is the one that, combined with VMware, gives our customers a tremendous amount of management and flexibility that they've never had before. You can increase or decrease the amount of resources you're delivering these apps with based on need. If that need changes, if it goes down, you can pull it back and reassign those resources elsewhere. Very, very powerful.
Or move the VM to another host and get it up and running very quickly. It's the little benefit of bringing both together.
Correct. Now, virtual PC, as I said, this is the land of the traditional sort of business office worker, right? So not maybe a 3D app, certainly, but whatever you do, don't dismiss the first one there, Office, right? We all know what the power requirements of a real PowerPoint presentation with a lot of animation is a graphical experience. And, I point to Word as an example because I think it's really easy to just sort of trivialize Word as just a bunch of text. But each one of those letters has 3D accents around it. And so if you're scrolling through a document, you expect those letters to move in a very fluid fashion. And that 3D element that makes it easier to read moves with those letters. And there's none of that sort of flat, hard to read end user experience. And so it's really important that we deliver all that for those users as well. Next, maybe more powerful, would be Virtual Workstation. Now, the difference between these two is Quadro. It's the ability to deliver essentially a suite of enhancements, of software, of physics, of leveraging parts of our hardware to deliver features and functions that, if you look at the application list, are absolutely critical to those users. Those engineers, if they don't have photorealism, the kind of ability to take an object that isn't real but make it look real, make it so that anybody who looks at that image would swear that McLaren is in my driveway, right? That's the sort of power that they expect. And so if you hear Quadro, you're thinking Virtual Workstation. And this is the one where now we've really begun to open up user types that have never been possible before. So if you look at this entire array of solutions, we've essentially addressed everybody in your organization. Your enterprise is now fully enabled.
And I think the important part about this, it's not just the capabilities here. I mean, NVIDIA's been working with these ISVs for many years to optimize and deliver their apps. Now you combine that with virtual GPU and Horizon, you can now deliver these high-end enterprise apps that are now certified on the complete solution. We look at Autodesk, we look at ArcGIS.
Correct.
And we look at Siemens, and we have all these apps that are certified end-to-end on both Horizon and vGPU. We can deliver the enterprise experience that high-end engineers need and deliver.
Absolutely. And in fact, now we've added Linux as well. So really, with this combined solution between VMware and NVIDIA, there is, as I said, there should be nobody within your enterprise environment that we can't address. So I want to talk about something sort of new and exciting today. The M6 and the M60 have been out now for a better part of maybe half a year or so. And something that's coming really soon that I want to address now is the M10. It's we've had the M6 and the M60 are very much about maximum performance, the ability to deliver all this horsepower, all this goodness, and still certainly get a tremendous amount of scalability. We're taking all these users, we're taking advantage of time slicing, and we're having an ability to put 16, 24, you name it, depending on the application, users per host, and really getting some decent scalability. But when we start moving into virtual PC, we start talking about those knowledge workers, there's a need for greater scalability where you can have a balance between performance and scalability. And so the M10, just like our K1 before it, is a 4 GPU, 8 gigs per GPU for a 32 gig total for the card, supporting a tremendous number of users. We conceivably could have up to 128 users per host. This card is really meant to be that scalability answer that people have been asking for.
I mean, the ability to add 2 M10s to a server to get that 128 users will let users and admins deliver that high scale they want to deliver from a single server, but with a richer, deeper, better user experience than they could ever deliver before.
Absolutely. And in fact, this graph shows some performance and density metrics that we have done with some initial testing. So this is spec ViewPerf 12, really a peak workload. So understand that this is really hammering the system. And I would say that with time slicing and some of the advantages around real users and how they really work, I would see better, honestly. And we have seen better with customers. But you'll notice that it starts with the Tesla M6, then the M60. And the M6 is a single GPU. Tesla M60 is 2 GPUs. And then the M10 is 4. And you'll notice that as it progresses, performance dips for the M10 because the emphasis is on scalability. Not that there's any performance problem with the M10. It's just when I need scalability, that's going to be what's important to me. When I need performance, that's what's important to me. And I have a choice.
And that's going to be a great benefit for users to be able to scale graphics throughout their entire enterprise.
Absolutely.
So now let's talk about using Horizon with Grid to deliver these high-performance graphics. Now, we take advantage in Horizon of all the hardware power that Tesla and Grid brings, and we then build Horizon on top of it to deliver that rich end-user experience by taking advantage of the APIs available in the NVIDIA Grid solution to give the best 3D user experience across the network. And that's really what matters at this point. You can deliver it in the data center, but now I got to deliver it over hundreds or thousands of miles and give you that rich, easy-to-use user experience to give engineers what they need. So what are the challenges that have been available for virtual graphics in the past? So first and foremost, designers, graphics users, they require a super snappy experience. It just has to work. It has to feel like it's native and local. And if you don't do that, users aren't going to want to use it, and it's always been a challenge. One of the other challenges in the past with delivering high-end virtual graphics has been it's been very hard to actually encode and deliver those graphics over the wire. It's been very costly. It takes more CPU usage, which again delivers less users, less of a better experience, and overall impacts what we're doing. And then finally, the amount of users we can get on a server is then limited by the CPU available. So if you look at all these challenges, there were a lot of challenges in delivering the user experience that people expect today from a modern PC. So, together with NVIDIA, we developed Blast Extreme. So Blast Extreme is a new remote display protocol part of Horizon 7. And what we've done is focus on each of those problems to deliver a better experience. By taking advantage of available APIs in the GPU, we can deliver a more interactive experience, up to 51 milliseconds reduced latency, so it is far snappier. To be able to deliver those applications remotely over long distance in video, we've been able to reduce the bandwidth usage from previous versions by up to 89% when used together with the GPU, so we can deliver more users with less bandwidth required. And then finally, from a density perspective, by leveraging the GPU to do more offload and encode in hardware, we can get up to 18% more users on the same server that we were getting before, delivering the same high-performance graphics just by taking more advantage of the GPU. And that's the advantage of the collaboration that VMware and NVIDIA have done together with our Blast Extreme protocol combined with the NVIDIA Grid hardware to deliver that great user experience.
Yeah, and let's be clear, back to the what was it, slide 1, right? We were talking about how it used to be or, right? I could do this or I could do that. This is the first time, and really working together is what produced this. We can say and, right? I want this and that, and I want all the benefit. I don't want some part of it. I want all of it, right? And it's also important to note that we, by having a platform and separating that, we were able to deliver that outside of our normal hardware refresh because it's software.
Exactly, take advantage of what we can do together.
Yeah.
So without Grid, let's see how it works today. So today, if I have a server with a Grid V GPU, we actually then we render the graphics, and then we go and we have to, on the CPU, we have to render and capture all the graphics to then transfer over the network. So it takes more CPU cycles. It reduces the interactive performance. It's still good because I've got a GPU behind it for video, but we can make it better. And that's where Blast Extreme comes in here, where the GPU handles the encode and the render all in one step. So we say, give us the graphics card directly off there and give us an encoded H.264 stream, so we're not having to impact the CPU on the server, so we can deliver that richer, more distinct experience.
Yeah, and from our perspective, right, we've already got it. Why should we hand it back to you?
Exactly.
Why can't we just encode it and hand it off?
Yeah, it was very inefficient before, but this is a far more efficient, better way to work and delivers a better user experience to the end user. And so you want to compare that to traditional CPU-based capture and code pipeline. Today, you would load the app, you would execute it, and then it loads on the GPU, it goes and it has to execute that workload, and then it goes through the CPU then to transcode it, take the image, encode it, packetize it, and send it over the network.
It's a heck of a journey.
Versus, okay, let's take advantage of the CPU version or GPU version. We can actually avoid these problems. And now, in the GPU case, we can just say, the CPU does its workload, the graphics get done on the GPU, it all gets all done in the GPU pipeline. It actually encodes it, captures it, encodes it, and then we packetize it and send it over the network far more efficiently, better scalability.
And for the audience members that just had their eyes, dilate because of the boom difference here, it's because we're massively parallel.
Yep.
This is what we're great at. This is what we do. This is taking advantage of purpose-driven hardware, years of experience with this stuff, and using all of our performance.
Exactly. So with Blast Extreme with NVIDIA Grid, we can reduce overall latency. We offload more workloads to the GPU. We increase our scalability, and we improve the user experience. Again, ands, not ors.
Right.
That's the most important part about this. We deliver everything the user wants. We deliver more of it. We deliver it better.
Yep.
And that's what the benefit of NVIDIA working with VMware is together.
So, just in real quick in summary, I think this is the and slide of all slides, really. And we've already drilled into most of this, but just remember, if there's one that I wanted to pick out of here, it's the 27 to 51 milliseconds less latency. If you think about how much farther away somebody can be and have the exact same experience they had before here, you are extending out your ability to deliver that globally. That's the important message.
So let's talk about how you actually take these technologies and determine how you're going to build your virtual desktops to deliver these high-performance graphics. So one thing that's really critical to understand is if you've delivered VDI desktops in the past, I'll get 200 users on a server, no problem. That's not what we're doing with high-performance VDI. Density is a lot less, and a lot more of CPU, memory, IOPS, and graphics is required.
Right.
This isn't your mom's VDI. This is delivering high-performance VDI for the right users and the right experience.
This is virtual workstation. It's really a different animal.
So some things to keep in mind when actually creating virtual desktops for high-end rich graphics workloads are, one, it requires vSphere 6 or later. Have to do this. We're not recommending anything earlier. This isn't a single CPU I can run the high-end apps on it. This is you're going to have to size this thing from 4 to 8 vCPUs for most applications. So if I'm going to deliver SolidWorks or I'm going to deliver Revit, I need at least 4 vCPUs, and for some apps, maybe even up to 8, depending upon how challenging those apps are. RAM. This isn't a 4 gig of RAM and I'm done. This is 4 gig of RAM is enough to boot the OS for these type of applications. We're talking realistically 8 gigs of RAM, 16 gigs of RAM for these types of applications we need to deliver. And then from a graphics and OS perspective, this isn't 32-bit Windows land anymore. We're talking 64-bit versions of Windows and Linux are required because these applications need far more memory than traditional OS delivery just for delivering Office applications. One thing to also keep in mind is that since we're delivering purpose-built virtual machines to deliver these high-performance applications, let's take advantage of getting rid of all the cruft you don't need when running in a virtual machine. Use the OS optimization tool available from VMware to cut down overhead that's not required in a virtual machine so we can deliver an even better user experience in a smaller size with less memory. So storage is critical. We've talked about today, NVIDIA helped solve one of the biggest problems with VDI, which has been graphics delivery. But the other thing that's been a challenge for delivering VDI desktops for years is storage. People have bought the wrong storage. It's been too expensive and not performant. And then their VDI stories fall apart. So if you don't look at storage as being a critical part of this equation, you will have problems. The great news now is VMware has Virtual SAN, which is included with Horizon Advanced and Horizon Enterprise. You can take advantage of vSAN-ready nodes and Virtual SAN to deliver high-performance storage required to deliver graphics applications. In fact, one of the largest AEC firms in the world has actually qualified their solution on top of Virtual SAN against high-end performance all-flash arrays. Why? It delivered almost identical performance at a lower cost, but more importantly, a single vendor to get support from. They don't have to worry about going outside to talk to a vendor for support issues around storage versus everything else. They now get an integrated end-to-end solution using Virtual SAN together with Horizon and delivering high-performance graphics.
So this is an interesting slide. This actually originated with our 60 and 60 from, seems year ago.
A little over a year ago.
Yeah. But long and short of it, and we don't have to maybe stay on this slide for too long because it's something somebody should pore over on their own, but understand that really, what we demonstrated is the blue section, where we did that actually in an hour. But the reality is there's a process that one should follow and go through in order to do this well. And if you do this, this isn't a 6 month, a year process, but it's certainly not a 2-day process. And it's something about being thorough and having things like end user acceptance criteria, having a clear understanding of the apps that you're going to virtualize and why. Because we've opened the door to so many new user types, it's just really important to get organized and manage that process.
And we have to reinforce those two. End user acceptance criteria. Yeah. That's always been a challenge. As you start looking at high-end, high-performance applications, you have to get your users on board.
Yep.
That's critical. Determine proof of concept, scope, and success early.
And quite frankly, testing with real users versus benchmarks is far more effective. That could be a whole other presentation. But
real applications,
yes.
Real workflows, real data. This is not going and downloading your favorite 3D game and running it. That's not what's successful.
Exactly.
And then get those pilot users to help you sell it internally.
Yeah.
That's the other thing to keep in mind. Get those pilot users to be there, to be the ones that are the advocates, to say, this makes my job easier, it's better than physical, it's a better user experience, and I can get my job done more effectively.
From anywhere.
From anywhere. So as a wrap up, a couple things we want to talk about, some things we've learned from our customers. So we've been doing this now for almost 2 years since we actually kicked off the collaboration publicly between NVIDIA and VMware with vGPU. And we've learned a lot.
Yeah, absolutely. And I was going to say that I think this slide's been used a lot, but what's crazy is every time we present this, it's nothing but nods from the audience, right? We never see there's no confusion, that's not me. One of these resonates with somebody, right? So like the 50% productivity gain, really the actual data points are 30 and 70%. But we've heard so many other examples now from customers about locating the data next to the compute and allowing the user to be anywhere means I don't have to move files back and forth, right? Tremendous productivity gains. If I have to open and close a file more than twice a day, even twice a day, and it takes maybe 15 minutes each time, because sometimes these files are huge and sometimes they're hours to open them, I'm saving huge amounts of productivity, right? And then I'm not going to go over every one of them, but like collaboration, if that particular engineering firm was able to get a group in, I think, Australia and another one in Amsterdam, but the data was in Georgia in the United States. Yeah. So being able to collaborate and be nimble allowed them to get business they would have not normally been able to win. And that's a game changer. It's an absolute game changer for enterprises.
Absolutely. And you look at the efficiency, the things that come with it. These companies are able to deliver things they couldn't have delivered before.
Correct.
To a wider variety of users. And it's funny, there's a company here, I'm just going to blend into the security side, where they used to have 7 workstation hard drives for each user that worked because they had 7 companies they worked with. And it would take them all day to go flip out the hard drives, reboot them, and get going again. By moving to VDI and using different virtual machines for each customer, they were able to get the security they needed and, more importantly, be more efficient in how they delivered things.
The value of that particular solution was staggering.
So some resources, if you go look in the chat, we can talk about some resources that are available to you. One wrap-up thing that's important to keep in mind is if you want to try this yourself today, you don't need to go buy any infrastructure. You don't need to try anything yourself. Go to the VMware NVIDIA joint test drive. With Grid Test Drive, you can access a VMware Horizon virtual machine backed by a Grid vGPU to let you try real-world applications, ArcGIS, SolidWorks, AutoCAD, and play back rich video. You can do this yourself.
Yeah, even just Internet Explorer and rich video. We put it all in there. And it's an opportunity for you to test yourself and then go to an executive decision maker and say, look, it works. It really works. You can also choose different data centers. So if you want to test remote access, you can from halfway around the planet if you like.
And you can do this without spending a single thing, $1 today. So you can try it yourself. So thank you.
Thank you very much.